Hello friends, today we will discuss one problem on RCC member subjected to predominantly bending moment and low value of compression and calculation of stresses in concrete and reinforcement. Calculation of stresses in concrete and reinforcement during the working load stage is necessary so that we can find out the crack width in the concrete, crack width in the structure based on the stresses in the reinforcement. Now, in this problem, the parameters are given like this. The cross section is 300 by 750 mm. It is reinforced with 416 torque on the compression zone, and it is reinforced with 428 torque on the tension zone. It is subjected to a compression of 120 kilonewton and also a moment of 220 kilonewton meter. The clear cover is given, therefore the effective cover can be calculated and it is shown in this sketch. Now our aim is to calculate the stress in concrete and also stress in the tension reinforcement. This will be useful for calculation of crack width in RCC structures. Now here the concrete grade is M25, for which the allowable stress is 8.5 Newton per millimeter square. And we have to calculate the stresses. Before that, we will discuss the free body diagram and also the various parameters to be calculated. This is the free body diagram. C is the compression offered by the concrete and C1 is the compression offered by the reinforcement in compression zone. Now ASC is equal to 416 torque, it is equal to 804 millimeter square. AST is equal to 428 torque, equal to 2462 millimeter square. Here concrete grade being M25, M, that is modular ratio, is equal to 280 divided by 3C, and that comes to 10.98. M is equal to 10.98. M is applicable for tension zone. For compression zone, 1.5 M minus 1 is applicable. This minus 1 is to take care of the duplication of concrete occupied by the reinforcement. The concrete area should not be considered twice. Therefore, for compression zone, this minus 1 appears. And for compression zone, the modular ratio is 1.5 M. And effective modular ratio is 1.5 M minus 1. It works out to 15.47. Now we will discuss the various parameters of the free body diagram. To begin with, this calculation of stresses involves assumption of one value for the neutral axis. Here, as based on repeated trials, the neutral axis is assumed as 290 mm. Here I have N is the depth of the neutral axis. Here we are assuming N value as 290 mm. This is based on repeated trials. After all, the value of neutral axis will be ranging anywhere between 0.3D to 0.4D. And based on the actual working, we can always increase or decrease in the subsequent trials. This value of N is equal to 290 mm is based on some trials. This is the value of N, that is 290 mm. This is the total effective depth. This is N. Therefore, this is D minus N. Effective depth minus N. That is equal to this much. This is the C, the stress in concrete in the extreme fiber stress, denoted as small c. C1 is the compression developed by the compression reinforcement. Capital C is the total compression developed by the concrete in the compression zone. The axial compression 220 kilonewton is acting at the mid depth of the section. Now we will calculate the arm distance for various forces. Now this axial compression 220 kilonewton is acting at the mid depth of the section. Therefore, its distance with respect to the tension reinforcement is 336 mm. that is half the depth is 375 mm. It is acting from the bottommost fiber at a distance of 375 mm. 375 minus this 39 works out to 336 mm. Therefore, 336 mm is the arm distance for this external compression, which is acting at the mid depth of the section. And now, what is the arm distance for capital C? Here, the depth of the neutral axis is 290 mm. Now, this CG of the total compression is acting at a distance of 290 by 3 from the topmost fiber. From the topmost fiber, its distance is 290 by 3. Therefore, that is coming to 97 mm. And this is 290 mm. Depth of the neutral axis, 1/3 CG is acting 290 by 3 is approximately equal to 97 mm. This is the point of application of compression offered by concrete. Therefore, its arm distance is equal to 614 mm. The effective depth is equal to 711 mm. 711 mm minus 97 mm is the arm distance for C, capital C, which is the total compression generated by concrete. Therefore, 711 minus this 97, effective depth minus this 97, CG of the compression is coming to 614 mm. This is the arm distance for this force C. Now, we will see the arm distance for the compression offered by the reinforcement. The total effective depth is 711 mm. The effective cover is 33 mm. Therefore, 711 mm minus 33 mm is 678 mm. This is the arm distance for the compression offered by the reinforcement. Now we will use the equilibrium equation sigma m is equal to 0 about the tension reinforcement. Here, the external moment is acting in the clockwise direction. It is 120 kilonewton meter. And then the movement due to external compression, this is also acting in the clockwise direction. We are taking the moment about the tension reinforcement. These two moment values, that is external moment and also the movement due to external compression, they are acting in the clockwise direction. Now, movement due to C, compression offered by concrete, is acting in the anti-clockwise direction. Movement due to C1, compression offered by reinforcement, is acting in the anti-clockwise direction. Sigma m is equal to 0 means the movement in the anti-clockwise direction should be equal to the movement in the clockwise direction. So, this is the movement due to the external force. This is the movement in the clockwise direction. This is 120 kilonewton external force into the arm distance 336 mm. And this is 220 kilonewton meter external moment. It is also acting in the clockwise direction. Now, this is the moment acting in the anti-clockwise direction offered by the compression developed in the concrete. What is the stress in concrete? Is average stress, extreme fiber stress is C. It is varying from C to 0 at neutral axis. Therefore, average stress is C by 2 into the breadth of the section, 300 mm, into the depth of the neutral axis, 290 mm. This is the total force, capital C. Its arm distance is 614 mm with respect to the tension steel. Now, what is the stress offered by compression reinforcement? The area of compression reinforcement is 678 millimeter square. This is the area of compression reinforcement into stress in reinforcement. Now, what is the stress in reinforcement? Stress in reinforcement is equal to 1.0 1.5 mm, 1.5 m minus 1 into area of this reinforcement. This is the area of the reinforcement. For equivalent area, you have to multiply it by 1.5 m minus 1. Then what is the stress in reinforcement? Stress in reinforcement is the extreme fiber stress to be calculated in the proportion. That is, at the extreme fiber, the stress is equal to C. That is at a distance of 290 mm. Extreme fiber, the stress in concrete is C. Therefore, at a distance of 257 mm, because the compression reinforcement is 33 mm away from the topmost fiber. Therefore, at a distance of 257 mm, the stress in concrete is C into 257 divided by 290. This is the stress and this is the area. For equivalence, the factor is 1.5 m minus 1, 15.47. 15.47 is 1.5 m minus 1. This is the equivalence factor, 1.5 m minus 1 into the area of reinforcement into the stress in concrete. This gives you the stress in reinforcement into the area. This is the total force offered by the reinforcement in compression zone. Area of reinforcement is this much, stress in concrete is this much. To arrive at the equivalence, this is the factor 1.5 m minus 1. Therefore, stress into area, this is the total compression offered by the reinforcement, and 678 mm is the arm distance for the compression reinforcement measured from with respect to the tension steel. This is the C1 force. This is the arm distance. So, in this equation for sigma m is equal to 0, the only unknown is small c, that is stress in concrete. And we can solve that, and C comes to 7.6 Newton per millimeter square. Now, let T be the stress in tensile. Now, we will use the equation sigma h is equal to 0. That is, all the forces acting towards right hand side should be equal to the forces acting towards left hand side. Now we have these two forces, C1, compression offered by reinforcement, capital C, compression offered by concrete. These two forces are acting towards left, and this external compression 220 kilonewton acting towards right. This tension in the tension reinforcement acting towards right. These two forces should be equal to these two forces. Forces should acting towards left should be equal to forces acting towards right. Now, this is the stress in tension reinforcement multiplied by the area of reinforcement in tension. This is the total tension. This is acting towards right. This is the external compression. This is 120 kilonewton. This is acting towards right. Now, the compression offered by concrete, C by 2 into the neutral axis into the breadth of the section. This is total value of C acting towards left. Now, the compression offered by the reinforcement, the area is 804. And now, what is the stress? Stress in concrete in the extreme fiber is 7.6. It has to be taken in proportion to the distance of the compression reinforcement. That is 257 mm divided by the neutral axis, 290 mm. So this is the stress. For equivalence factor, the factor is 1.5 m minus 1, 15.47. Now, in this equation, the only unknown is T, and this is coming to 120 Newton per millimeter square. T is equal to 120 Newton per millimeter square. We have already solved for C is equal to 7.6 Newton per millimeter square. Whether these are correct values or not, it has to be verified, because we have assumed the value of neutral axis N as by trial and error. N is equal to 290 mm. For the assumed value of 290 mm, we have calculated the stress in concrete and stress in reinforcement, and that is equal to 7.6 Newton per millimeter square and 120 Newton per millimeter square respectively. Now, for the calculated value of C and T, there is a relationship between the neutral axis. That has to be established. If C and T values are given, then the neutral axis N1 corresponding to the value of C and T. T is 120, C is 7.6. The value of N corresponding to the value of C and T is given by 1 divided by 1 plus T by MC into the effective depth. This is 1 divided by 1 plus 120 is the stress and reinforcement T. M is 10.98, C is 7.6. N, the relationship between N for the calculated stress C and T. The relationship for N in terms of the stress calculated in concrete and reinforcement C and T is given by 1 divided by 1 plus T by MC into effective depth. This is obtained by the straight line relationship. This is C, this is T, this is N, this is D minus N. Therefore, N is equal to 1 divided by 1 plus T by MC into D1. This is the straight line relationship. Now, for the calculated value of C and T, we are finding out the value of neutral axis, that is coming to 291 mm. This is same as 290 mm, which we have assumed after repeated trials. This is more or less equal. Therefore, the assumed value of 290 mm can be taken as correct. Suppose if this value of N1 comes to 300 mm, then you have to repeat the trial by increasing the value of neutral axis. You increase the neutral axis value from 290 mm to 295 mm because you have assumed N as 290 mm, and if this is coming to 300 mm, then you have to increase this value to by some mm. Therefore, you can assume the next trial as 295 mm. Suppose if this actual value of N based on calculated value of C and T is coming to 280 mm, then you have to try the next trial by reducing the value of 290 mm to 285 mm. Then the convergence will take place, and there is no difficulty in this. You have to make 1 or 2 trials in the range of 0.32 to 0.3D to 0.4D. Then you will get convergence. Now, this is how the stresses are calculated in concrete and reinforcement. This is useful for water retaining structures where we have to do the check for crack width, which is restricted to 0.2 mm. And for buildings also, strictly speaking, we have to check for the crack width, and it is specified anywhere between 0.35 mm to 0.4 mm. And this is available. This is available in my website, rgmsite.wordpress.com. rgmsite.wordpress.com. It contains RCC problems for various stress analysis, strength analysis, university questions, and university questions on strength of materials, structural analysis, steel design, etc. Nearly 500 university questions have been addressed, university questions and answers, and the download is free. Please visit my site, rgmsite.wordpress.com. Let me repeat, rgmsite.wordpress.com. The download is free. Thank you all.